Hello, this is Jeffrey Fox. I'm the instructor of the Big Data Applications and Analytics course, the general overview of applications of big data. We're doing sports analytics or informatics, and we're doing in the other sports, meaning other than baseball. And we're going to look at, in this lesson, lesson 3 of Unit 3, National Football League, American football, and American basketball, NBA. And when we look at that, we'll find that the discussion is qualitative and focuses on spatial visualization of displaying what's happening as a function of position on the playing field for these two games. And we've seen this that this data can either be used in two sort of actually related ways. One is giving you a good feeling as to what's going on in the 3D world where these games are played, and the other is taking a slightly deeper look at that data and predicting what's going to happen, or how you should actually play the game so that the result is more in your favor. Okay, so here we have our first example of spatial visualization, where we have a set of hexagons, where the color of the hexagon represents the completion percentage, going up to dark red for 100% completion, and these light green colors as the worst case. The size of the symbol represents the frequency with which the ball is thrown by the quarterback to this particular location. So he throws it backwards here or forwards here about the same fraction of times. Here we have an orange, which is a reasonable completion rate, but not nearly as good as the completion rate here. The completion rate here on the right-hand side is actually a little better than the completion rate on the left-hand side. And of course, here we have the long throws, where that's the thing that makes the game exciting, and they tend to be near the edge of the field for obvious reasons. And these are quite small, and they're lightly colored. They were not thrown so often, and they don't have such a great percentage completion rate. So this visualizes for you, if you were a quarterback or a coach, where you might want to throw to get a certain expectation of success. And that, of course, is folded into the state of the game, the number of downs, how many yards to go, and so on. All right, and here's the same type of data where the color represents the completions percentage. Here we have the high percentages backwards, and here we have a high one forward on the right, and here we have other ones. I mean, this highish completion is backwards and a little bit forwards, and then we have the edge of the field with a lot of long throws and a scatter of long throws throughout the whole field. And the dots represent, these are now no longer symbols, these are just dots representing individual individual throws. So this gives you this is another way of looking at the same type of information about how often, this is for all passes in 2012. So actually these are not individual throws, these are just average throws in that particular small spatial region. Here we have the same type of data again with fractions of times they're chosen. So you can see the typical throw is actually around in 0 to about 7 yards forward. And then we have some tiny ones in the center of the field long, and some non-trivial number. So if you add up these numbers here, they're going to round up around 10%. So 10% throws for more than 20 yards, dominantly on the sides. And it must be that we have slightly more on the right-hand side, because maybe that's right-handed quarterbacks prefer to throw there. That I don't know. As we've noted, the right-hand side tends to be somewhat more successful and than the left-hand side. And now here everything represents probability of actually choosing this throw. It does not actually say the successes. So this is spatial visualization for American football. Here's an interesting talk I found from a computer science department at University of Illinois at Champaign, Urbana-Champaign. And it's obviously, that's a top-class school, so these must be top-class people. And what's interesting is that they're using what I pointed out. You can take video, and here you can identify what's going on from the video. Here we have the people identified, and you can translate those into movements, and then you can take these movements on a play and try to do machine learning to classify movements into types of play. And so that's what they're trying to do here. They're trying to find automatically the types of plays that are used in the I don't know whether this is college sports or National Football League. Illinois is a great computer science department. It's not a great American football team. It's not terrible either. Okay, so now we come to similar discussion for the National Basketball Conference, American Conference, and this comes from the same talk, which has this overview of sports analytics from the MIT conference. And this takes a particular player who's meant to be a very good shooter, Jose Calderon. And here we have a plot where the size represents the frequency. Here we have low to high frequency. And here we have the efficiency, the percentage of success. And red is above average, and green is not so good. And you can see there's some rather clear systematics here. We have this line here must be the 3-point line. And here this fellow is pretty successful in this range here, just outside the 3-point line. He's 40 to 50% success. Inside there, he's somewhat higher because it's a shorter shot. He's very good near the hoop, but he's not so good shooting from the side here, 40% green and yellow around here. So this fellow you would use from this region or here, but you wouldn't use him from the edge. Here is Martell Webster, who is not nearly as good at three-pointers, significantly lower percentage. Really excellent from the left, not so good from the middle, and actually weak from the middle, and not so good from the right. So he has rather very different statistics from Calderon. Here we have a third player, again extremely weak as three-pointers, very strong here, these mid-range side shots. It doesn't actually shoot much from the center here, and he's not so good from the hoop, although not as bad as the previous one, I think. So this tells you where the players should try to arrange plays to position the players in their comfort zone where they're just super shooters. That's presumably the purpose of this. Here we have a great player, LeBron James, is possibly I gather the currently most valuable player in the NBA. He's a very good three-point shooter here, not so good on the right. He's extremely good from the middle. And remember the previous person was wonderful here and not so good here. This fellow is really incredible in this region here. And also excellent from the left, but not so good here. So it is really kind of clear systematics. And here is again where we have each dot here. It tells you actually how many attempts there are in each dot. It's 20 field goal attempts. And you can see where all the attempts are made from. We have a lot from just outside the three-point range. Obviously, not so many here, places like here, because if you're going to shoot from me, you might as well just drop back a foot and shoot from the three-point, outside the three-point boundary. And then, of course, a lot from here, where it's much closer than the three-point range, and it's still farish from the hoop. So you're not going to get blocked and defended as effectively as you are in this region here. And of course here you're right at the hoop and you have a different style of play. And again, we have these interesting edge shoots, which are very popular type of shooting. Here's a measure of efficiency, where again the size represents the number of attempts at a given location. With the large size, many attempts, and the points go from reddish for the highest highest percentage success to blue, which is the worst. And you can see this region here is not good. It's presumably very well defended. And here from the 3 points, and it may be the way they've done the coloring, because you're getting 3 points, you automatically get more marks than if you shot from a 2-point range. Anyway, this is a huge number of amount of data showing very clear systematics as to where it's a good place to shoot from. So this is all examples of spatial visualization, of trying to explain where in this case, either in the NFL, we were saying where the quarterback should throw the ball. Here we're saying where the basketball player should shoot the ball from. So this is, I say, these shot maps from the 26 to 2011 data, and it sort of summarizes the whole tendency in shot attempts and points per attempt. And as we've explained, the larger the size of the square, indicated data where many field goals are attempted, and the smaller squares where there are fewer attempts, and the color tells you the percentage acceptance. And blue is bad, and orange and red are very good. That discussion there on that slide was for the previous two pictures. So here we do the same type of picture, but we do it for individual players, and we have 4 different players here, and you can see here's Steve Nash, Ray Allen, Kobe Bryant, I know, Dirk Nowitzki, I just don't know these 3 players here. Here is Bryant, who's a superstar, and you can see again these players are reasonably different. Namely, this player here, Ray Allen, doesn't have many shots at all from this mid-range region, whereas Kobe has quite a few and actually reasonably successful. Here, the greens and the yellows are going to be the yellows is the higher than the green. So he has reasonable thing here. He has some blues, which are bad probabilities. And of course, here he have 3-pointers from this side area here, quite successfully. And so anyway, here's a fellow, this is Nowitzki, terrible from the side, hardly does it at all. Pretty wonderful from the center here, which is better than Kobe. In fact, he's by far the best from the center of these 4 people, and a very solid player from this mid-range band. So, these just point out that here's obviously a 3-point shooter, very little inside, and quite a lot from the outside, and very few here from the edge, unlike this fellow here, which has a lot from the edge. All right, the final picture here just describes that slide, and these have high ranges, they're good from far away, and they do that in pretty different ways. And as we saw, Nowitzki was this fellow who's incredibly good from mid-range, and Ray Allen was a fellow who was good from the very corners, the left and right corner, and Steve Nash rarely shot from those particular corners. So it really shows out striking differences between different players. Quite what this translates to is not so obvious to me, because it doesn't translate into it presumably tells you how you have to arrange the ball to be passed between players and where players should aim to get to, because They want to get to a place where they have a good success. Of course, they probably know where they have good success, and they tend to go there automatically. So this is not probably new data for a lot of the players, but it's still interesting to see it displayed. But this is visualization. We're using spatial visualization to plot out the plays and the game as a function of position.